Caltech's new method to measure quantum errors. Quantum computers hold the promise of surpassing classical computers in solving complex problems across various domains such as computer science, medicine, business, chemistry, and physics. However, these advanced machines have yet to reach their full potential, as they currently struggle with inherent errors. Researchers are diligently working to minimize these flaws and enhance the performance of quantum computers. One way to study these errors is to use classical computers to simulate the quantum systems and verify their accuracy. The only catch is that as quantum machines become increasingly complex, running simulations of them on traditional computers would take years or longer. Now, researchers at the California Institute of Technology, Caltech, have invented a new method by which classical computers can measure the error rates of quantum machines without having to fully simulate them. The team describes the method in a paper in the journal Nature. In a perfect world, we want to reduce these errors. That's the dream of our field, says Adam Shaw, lead author of the study and a graduate student who works in the laboratory of Manuel Endres, professor of physics at Caltech. But in the meantime, we need to better understand the errors facing our system, so we can work to mitigate them. That motivated us to come up with a new approach for estimating the success of our system. Quantum simulators and entanglement. In the new study, the team performed experiments using a type of simple quantum computer known as a quantum simulator. Quantum simulators are more limited in scope than current rudimentary quantum computers and are tailored for specific tasks. The group simulator is made up of individually controlled Rydberg atoms, atoms in highly excited states, which they manipulate using lasers. One key feature of the simulator, and of all quantum computers, is entanglement, a phenomenon in which certain atoms become connected to each other without actually touching. When quantum computers work on a problem, entanglement is naturally built up in the system, invisibly connecting the atoms. Last year, Endres, Shaw, and colleagues revealed that as entanglement grows, those connections spread out in a chaotic or random fashion, meaning that small perturbations lead to big changes in the same way that a butterfly's flapping wings could theoretically affect global weather patterns. The researchers estimated that their 60-qubit quantum simulator operates with an error rate of 91%, or an accuracy rate of 9%. That may sound low, but it is, in fact, relatively high for the state of the field. For reference, the 2019 Google experiment, in which the team claimed their quantum computer outperformed classical computers, had an accuracy of 0.3%, though it was a different type of system than the one in this study. Shaw says, "We now have a benchmark for analyzing the errors in quantum computing systems. That means that as we make improvements to the hardware, we can measure how well the improvements worked. Plus, with this new benchmark, we can also measure how much entanglement is involved in a quantum simulation, another metric of its success."